Hello and welcome back to your lectures. So today we're going to talk more about functions. Now hopefully you're not too confused, but I know that functions are a really large topic and they're a really big part of programming. So just having a couple lectures on them can be make you feel like you've only skimmed the surface of functions. So today's lecture is going to supplement the last lecture that we had on functions, and I'm going to give you a little bit more examples and also go more in depth on some of the things I touched on in the functions lecture. Okay, so remember the syntax of making a function is using this def keyword, then the name of the function, parentheses, and inside the parentheses are arguments for the function. And remember, arguments are things that we bring in from outside our function in, so those are the inputs. And you should think about this as things that are different almost every time that we run the function. Okay, so for instance, I have this very simple function called string printer. And what this does is it takes in a string as an argument, and literally all it does is print that string. Now, I didn't say this is the most useful function, but it is a function that works. So what I can do is I can define the function, and this part that I've highlighted is the definition of the function. Now remember, when you have defined a function, you have told Python to do or told Python what to do in case you ask it to do something, but you haven't actually asked it to do anything yet. So if I comment out these invocations of the function, if I just run this by itself, Python thinks about it, it runs it, and what Python has done is it has stored this function, but you didn't ask it to run anything, so it hasn't actually run anything. The way that you ask Python to run a function is by calling it, and remember that is done by saying the name of the function, parentheses, and then giving it any and all arguments that it needs. So for this call to the function, I'm asking it to print out welcome to today's lecture, and then in this call of the function, I'm asking it to print out hope you had a great weekend, or have a great weekend. So when I run this, now you can see that something's actually printed out, and that's because using these two calls to the function, we have actually asked the function to do something. Okay, so I briefly touched on this, and you actually may have run into this in the code that we've done so far in class, but there's different ways that you can use a function. So the function that I just defined up here that prints something, that has an input, but it has no output. So it does something. Having no output doesn't mean that the function does nothing. It just means that we haven't returned anything to the user. And remember, the return statement allows us to have access to anything that we've calculated inside the function. So I have two versions of the exact same function called PowerMaker, and this essentially raises one number x to the power y. The first version calculates it and prints it, so we'll be able to see it on the screen as a user. And the second one calculates the power and then returns it. Now, the difference between these two is that once this function is done running, we have not returned p, so while we can see it, we don't have any way of storing it to use later. Now, sometimes in functions that's okay. You know, in this function that we did here with the printing, we don't really need to store anything. But in this function, it might be useful to store it, right? Like, I don't want to calculate the power of something just for fun. I usually do it because I need it later on. Okay, so I just want to show you the difference between having a return statement and not having a return statement. So I'm going to set this variable myPow equal to PowerMaker62, and remember that's this one up here. And then I'm going to set myPow2 equal to the output of PowerMaker2, this function of 6 and 3. So remember, this should take 6 and raise it to the power of 2, and this 6 to the power of 3. So remember, when you set a variable equal to the output of a function, it'll store whatever you return inside that variable. Okay, but no, and I'm giving you a little bit of a spoiler here, we didn't return anything in PowerMaker. So what's going to happen? I don't know. Let's go ahead and see. So we're going to store both these variables, and then we're going to print both these variables. Okay. Well, so when we ran the first one, we printed the output. 6 squared is 36. But notice when we're printing down here, we said my POW is, and we printed it out. Oh, it says none, not 36. Okay. Well, you may have run into this before if you accidentally set a variable equal to a function, maybe like a string function or a list function that doesn't return anything. And what happens is if you don't have a return statement and you try and set a variable equal to the output of that function, Python goes, well, okay, but there's no output because you didn't return anything. Remember, return is how we tell Python what our output is. And so Python will do this. It won't give you an error or anything, but it just goes like, all right, I'm gonna store nothing. And so whenever you try and use that variable, or here where we tried to print it, it'll just print out none because you've stored nothing. Here, on the other hand, when we said my POW2 is, we did get the answer, which apparently is 216. And that's because we did return something. So when we set my POW2 equal to the output of that function, we returned something. So there is an output to store in my POW2. Okay, so I mentioned in our list lecture that lists are mutable. That means that once they've been created, we can change them. And we saw that using append or remove or insert. We can take a single list object and we can add things, remove things, whatever. Now, this is an interesting concept with functions because remember I told you that when a function runs, the script pauses, it goes and finds the definition of the function, runs the function kind of in its own little world, and then comes back to the script after returning any output that you asked it to return. So that means that any variable that was created inside the function is deleted. And similarly, we'll see that any item in the function that is changed. So if we have a variable that is equal to 0, and then inside the function we change it to 1, you'll actually find that outside of the function, the variable didn't change. That's because things like integers and strings are immutable. Now we can change mutable objects. Okay, so we learned so far that lists are mutable and dictionaries are mutable. So what happens is if I define a function called listChanger, put in the variable mylist, and I say mylist.append 8. Okay, so what we've learned so far, my prediction would be that, okay, well, we'll like append 8 to the list, but then once we're done with the function, that gets deleted and our list will just be the same as it was originally. Well, that's actually not what happens. And this is because mutable objects can be changed inside a function and they remain changed once the function is done. Immutable objects do not remain changed once the function is done. So actually, let me edit this function so I can show you. And let me put a new variable, so b equals 0. So I can say, okay, well, inside my function, I am going to add 1 to b. And actually, let me feed that into the function. So I'm going to add 1 to whatever number we put, and I'm going to append 8 to my list. Now, I'm not going to return anything, but when I run my function, we're going to go ahead and run the function, and then I'm going to print A and then print B. Okay, so remember defining the function, declaring some variables, calling the function, printing out the output. So when we run this, notice our list afterwards, and remember we're printing this after the function is run, our list does have an 8. The change we made inside of the function remained after the function was done running. Our integer, on the other hand, when we printed b, that's still 0. Even though inside of our function we changed it, it is still 0. So remember, that is because mutable objects can be changed inside of a function. Immutable objects cannot be changed inside of a function. So you can add something you can add something to it or change it inside the function, but once the function is done, immutable objects will revert back to their original value. And we can see that knowing that b is 0 here when we would have thought maybe b would be 1. Okay. So I also mentioned that functions are really useful for things that we do a lot, right? So if we're going to write the same line of code over and over and over and over, especially when it's multiple lines of code, we probably want to write something that does it for us so that we don't have to type out all those lines of code over and over and over and over and over and over and over. Okay. So we've done a lot of things checking whether the length of strings is even or not. So maybe I want to write a function to do this. So to do this, I say def even length checker and say, okay, I'm going to give it a list as an argument. Okay, so I can say for w in a list, what am I going to do? Well, first I want to say if w, actually if len w, because remember we're checking the length, oh, can't type, if len w, and that's just going to be an integer, right? An integer telling us the length of the list. If len w modulo 2 equals 0, and remember we know this means if the length is even, return true. Else, and so that means if length modulo 2 is not 0, return false, because we know that means that it's not it's not even, excuse me. Cool. So let's write another function, and this is actually something we've done in class before. So we're going to write a function called 5 and 7, and it's going to take in one number, and our job is to check if it's divisible by both 5 and 7. So I can write a really simple loop and say if n modulo 5 equals 0, so if it's divisible by 5, and n modulo 7 equals 0, return true, else return false. Okay, so like if I want to run this, I could say, we'll say bool, because it's going to be a true or false value, boolean, there we go, that apparently was a keyword. So boolean equals, and the output of 5 and 7, and remember the reason why I can set a variable equal to the output of this function is because this function returns something. And so we'll check the number 68. So when we run this, and actually let's go ahead and print it afterwards so we can just see what it is, this should return either true or false. Or it should return true if 68 is divisible by 5 and 7, and false if it's not. And when we run that, Python tells us, oh, well, apparently 68 is not divisible by both 5 and 7. Okay, so I'll give you a little bit more of a drawn-out example, and this is something called a perfect number checker, and so I'm going to call my function perfect number. And what a perfect number is in math is a number where all of the divisors of that number add up to the number. So for instance, if I wanted to check for the number 6, well, what are the divisors of 6? 1 and 6, 2 and 3. Okay. So I can go ahead and say, well, do all of the divisors except the number itself, obviously, add up to the number? Okay, well, 1 plus 2 plus 3, oh, that's 6. So all the divisors of 6 except for 6 added together equals the number, equals 6. And so that's how we determine whether something's a perfect number. This is just a thing that happens in math. Don't worry too much about the math behind it. Just remember we're going to have to calculate the divisors. And then we're going to have to add all of them together. And then we're going to have to see if that number equals the number that we are checking. So we're going to define a function perfect number, and it's going to take in one number for us to check whether it's a perfect number or not. Okay, so I need to find all the divisors. So first what I'm going to do is make a empty list called divs. And then I'm going to write a while loop. And this while loop is designed to check all of the numbers less than our number n to see if they're a divisor, right? Because we can't have divisors that are bigger than the number. Okay, so we can say for I in range from 1 to our n if n modulo I equals 0. So if our number is evenly divisible by this number that we're currently checking, divs.append I, right? So if it is a divisor, that's what we're saying here, add it to our divisor list, okay? So once we're done with this for loop, we should have a list of all the divisors. So we can say, okay, well, what is the sum of all the divisors? So I'll call that S. So S equals sum of divs. And this is actually not of diva, of divs. So this should give us the sum of all of the numbers in the list. And then we're going to check if S equals our n, so if the sum of all the divisors is equal to the number, here we'll print, so print perfect, else print not perfect. Okay, so we can go ahead and run this, and oh, Python didn't do anything. Why didn't it do anything? Well, because we didn't ask it to call the function. So it stored the function but not used it. Okay, so what do we want to check? Well, we can say perfect number 6. And we already know this is a perfect number, so we know what it should output. Cool, so it did tell us that 6 is a perfect number, which we already knew. So let's go ahead and try another one. How about 25? Go ahead. Oh, 25 is not a perfect number. How about 28? And 28 is a perfect number. So we could check any number that we want in order to see if it's a perfect number. Okay, so I asked you, or I told you rather in the last lecture, that functions are mostly useful because we can reuse them, right? If you're going to write a function, you want to be able to use it more than just one time. Otherwise, why would you write a function? You're just going to write like the couple of lines of code on their own. So this is an example of a pretty frickin' useless function. It's called cups to tablespoons, which, pretty useful. And I say, okay, cups equals 1 and return 16 because I believe there are 16 tablespoons in a cup. And then if I use this, okay, like fine, but it's only ever returning 16. I can't put a number of cups that I want and then change it into tablespoons. I can only ever convert 1 cup to 16 tablespoons. So this isn't really useful, right? It's only useful in the one instance where I want to convert 1 cup into tablespoons, excuse me. Okay, so how could I make this reusable? Well, first of all, I probably need an argument, right? Because if I don't bring anything new in, then I'm not going to have anything new to work with. So I'm going to have C be a variable that we put, or an argument that we put in our function. And then I'm going to say tablespoons equals C times 16, right? Because the amount of cups that we have times 16 tablespoons per cup would be the number of tablespoons that we need. And then instead of just returning 16, I'm going to return tablespoons. So now when we run this function, Python is ready to convert any number of cups for us into tablespoons. And let me just show you how that would work. So we can say T's equals cups to tablespoons, and I want to convert 3 cups. And so when I run this, and then let's print, yes. When I run this, I can see that, okay, well, 3 cups is equal to 48 tablespoons. Okay, so here's another example. So I mentioned this when we talked about while loops a little bit, but sometimes you want to check multiple conditions, right? So you say, okay, I only want a number that is divisible by 4, 5, 9, 3, and 11. Okay, so that's a lot of things to check. And if we have an if statement like this, this is slightly bulky. And if we used a while, again, it would be slightly bulky. So what I can do is I can create a function, and you know what, let me even shorten that name to MC. So this is our modulo checker, and it takes 2 arguments, n and m. And n is the number we're checking, and m is the divisor that we're checking. And so what I did is I defined this function, and I said if n modulo m equals 0, return true, else return false. So essentially what we have is a function that returns true if n is divisible by m, and false if n is not divisible by m. And so what I could do is make this if statement a little more efficient. So I could say if MC, what is our number? 2934. Well, let's store that. We'll call it K is 2934. So we're modulo checking K with 4 and modulo checking K with 5. And we'll just copy this. So 5 and 9 and 3 and 11. Now, this may not look too much more efficient, but you can imagine if we're doing this multiple times, then this can really save us both some room, making our code look more elegant, and time, because, you know, this is a lot of characters to write out. Okay, so these two things are now exactly equivalent, but one looks a lot neater than the other one. Okay, so I want to give you an example from the pigs homework that you did, and I know that was a very difficult assignment, but I could write a function to help me out and make my code a heck of a lot more simple. And I just want you to know, this entire thing is your entire pig assignment, okay? And I know I've seen some of your code, you guys have a lot more code than this. And this is because functions help you make your code shorter, easier to read, and more elegant. Okay, so what this function does, my turn, is it runs either a human turn or a robot turn, depending on if this robot boolean is true or false. So I start like you guys may have started. I say import random, I roll. So remember, this is one turn. So I roll, I add the points for this turn, or I add roll to the points for this turn. Then I say if it's a robot, while roll is greater than 1, so while I didn't roll a 1, and my points are less than 20, so the number of points I've earned this turn is less than 20, randomly choose between 0 or 1. If it's 0, that means I want to roll again. So I roll, I add my points to the roll. Otherwise, so if they hold, I add the points for their turn to their total points, which I fed in as an argument, and then I stop my loop. Okay? And then otherwise, if it's not the robot's turn, so when you're human, I roll and you do the exact same thing, except instead of having a random integer choice between roll and hold, I ask the user whether they want to roll or hold. And then at the end, I return the total points. Remember, so we feed in the current amount of points they have, and then I change it inside the function. But because an integer is not a mutable object, I need to return it in order to store the current value, and I also need to spell it right. And so this part of your function, this is the entire game. It is very few lines because we have all of the main code in a function, which is very neatly stored up here. So what I do is I set robot points to 0, human points to 0, and I say, while no one has won yet, run a human turn, and then if the human didn't win, run a robot turn, print their scores, and then we're going to loop up over and over and over until someone has won. Okay. So I'm just going to leave the screen on this for 1 second. If you want to pause the video and look at it so you can get more familiar with that, this is the time to do it. All right, so I'll assume you've paused and read it. So we're going to take a quick detour from functions and talk about two other kinds of collections that we skipped over when we were talking about lists and dictionaries. So the first is tuples. And tuples, while having a silly name, have an actual purpose in programming. And actually, you can think of a list as a immutable list, you can think of a tuple as an immutable list. So it has almost the exact same functions as a list. The only thing is you can't change it like you can change a list. So to declare a tuple, you can use parentheses. You can say parentheses and then item, comma, item, comma, item. But actually, this line is equivalent to this line. So parentheses are very helpful to make your code readable, but the important part of declaring a tuple is just that you have an object, comma, object, comma, object. I mean, you can have more than 3, by the way. So I'm going to put back the parentheses because I think they look nice. So I can do things with a tuple that I came with a list. Like, for instance, I can create a new tuple and say that tuple equals my original tuple plus my original tuple. I can also loop through them. I can iterate for them since they are collections. And I can check if something is in them. So I can say A equals 1 in tup. So if 1 is in the tuple, A will be true. If 1 is not in the tuple, A will be false. So let's go ahead and run those. And we can see that when I print my tup2, that'll give me the item at index 2, right? And so 0, 1, 2. Okay, so it did print out 3. And then I iterated through it and I said for item and tuple, or for I and tuple, print the item. And it did. It printed 1, 2, and 3. And then it printed out true because I can use the in operator the same way that I do with a list or a string. I can say, is the integer 1 in the tuple? Well, yes, it is. So Python printed out true. Now, you can't use list methods on tuples that change the list, okay? Because remember, a tuple is a immutable list, so we can't change it. So if I try and append something to my tuple, well, that doesn't work because, and Python will give you this error, because we can't change the tuple and append as a function that tries to change a list, so we can't use it on a tuple. So remember, list methods that don't change the list, totally valid on a tuple. List methods that do change a list, not valid in a tuple. Okay, and I get some questions sometimes about like, okay, well, like if we already have lists, why do we need to have tuples? They seem very similar. In fact, a tuple seems like a list with less features. And that's true. And I don't want to get into the details of it too much, but tuples, since they're not able to be changed, are more efficient to store on your computer's memory and are more efficient to work with. And the other nice thing is that you can't accidentally change them. So if you are ever in a situation where you are programming something that other people will interact with, maybe you're making a game or an app or something, and you want something that is both fast, and you know you're never going to have to change it, so it's both faster and no one can accidentally change it in your code, that is super useful, and that is why we use tuples. Also, Python natively uses tuples for certain things, and we'll talk more about that later. But for now, just know that's the reason why we sometimes use tuples, is because it's more efficient, and also it means that we can't accidentally change it. Okay, and the last collection that we will talk about today are sets. And sets are also sort of like lists, although they do use curly brackets. So remember, curly brackets we think of as being a dictionary, but if we don't have these colon key value pairs, if we just have what looks like a list inside of curly brackets, Python knows that that is a set. And a set is similar to a list, except for that it only stores unique items. And the way that I tell Python that I want to declare a set or like create a set is by putting curly brackets and the items of the set that I want to be in there. So I created this set, my set, and then I can print it. And when I run this, Python prints out my set for me. But I also want to show you, so what happens if I try and declare a set that has duplicates in it? Well, Python says, no thank you, and it will get rid of those duplicates for you. So you can see that the sets that I declared, my set and my set 2, are the same when we print them out, even though I put a bunch of duplicates in my set 2. So Python will go in, it'll look for those, and it will get rid of them for you. So one thing that we can do, and actually we did a classwork like this where we had to find and remove duplicates. If I have a list called L and it has a bunch of numbers with some duplicates in it, if I create a variable called new set and I say set L, and set is just a constructor, the same way we turn things into strings or ints or floats, a set will turn whatever you put into it into a set. So if we take a list and turn it into a set and then print out that set, what Python will do is take this list, change it into a set, which means getting rid of all the duplicates, and then store it in this nice variable for you. So when we run this, we can see that it took my original list, removed all the duplicates, and printed it out as a set. Okay, so sets are really useful for times when we only need unique elements. It's very useful in math. And also you can see, like, if you need a cheap and easy way to get rid of all the duplicates, you can always turn something into a set. So these aren't as common as lists or dictionaries, but they definitely have their uses, and they are, very practical if you're doing a lot of math. All right, that's all I have for you guys today. Let me know if you have any questions, and I will see you next time.